Good morning children. Today we are going to see a new topic which is prime number and composite number. Before that, in last class we didn't solve the fourth one. We are going to solve the fourth one. So they asked us to find the multiples of 9 below 100. So 1 to 100, the multiples of 9 we are going to write. That is, we are going to write the 9 table till you get the number 100 or before that. So 9 ones are 9, 9 twos are 18, and you are writing the 9 table. At 11, 9 into 11 you will getting 99, which is less than 100, and after that you will get 108, which is greater than 9. So till 11 you have to write. Now we are going to see prime number and composite number. Before that we are going to see the numbers and their factors. So here you are seeing the numbers from 1 to 10 and their factors. 1, for 1 only the factors, that is only one factor for you, 1, and it is 1 itself. For 2 it is 1 and 2. For 3 it is 1 and 3. For 4 you can write 1 and 4. You can write 4 into 2 terms, 2 into 2 also. So it is 2 also. For 5 it is 1 and 5. For 6 it is 1, 2, 3 and 6 as you learned before. And then for 7 it's 1 and 7. For 8, 1, 2, 3, 1, 2, 4 and 8. For 9, 1, 3 and 9. And for 10, 1, 2 and 5. So if you see here, other than 1 you can find more 2's. Right, everything else here you have 3, 4, 4, 4, 3. So now it gives us an idea of what is prime number and what is composite number. 1 is neither a prime number nor a composite number. Prime number is one which its multiples or factors are only 1 and itself. They have only 2 factors. Okay, so prime numbers are one such number that has only 2 factors, which is 1 and itself. So 2, here you can find 2 is a prime number, 3 is a prime number, and here 5 is a prime number, 7 is a prime number, and rest all other numbers are composite numbers, which means if they have 3 factors, 4 factors, no matter how many factors they have, they are all come under composite number. Prime number means they have only 2 factors, which is 1 and themselves itself, or the composite numbers they have more factors. Okay, for example 4 is a composite number which has 1, 2, 4, which means 3 factors they have and they are composite number. And 5, when you look at 1 and 5, only 2 factors, that is 1 and itself. So they are prime numbers. 1 has only 1 factors and it is neither a prime number nor a composite number. So now we know what is prime number and composite number. There is a method of finding prime number and composite number which is easy. I am taking only till 20 to find the prime number and composite number. So here 1 is not a prime number, neither a composite number, so we are striking it out. 2 is a prime number, so we are circling it. 3 is a prime number, we are circling it. So 2 multiples are all composite numbers. If you multiply 2 with 1 you will get 2, but it is prime number. And 2 into 2, which means 4. You can strike down all the multiples of 2 because they are not prime numbers. They can be written in terms of 2. Okay, now leftovers we are going to see. Here 5 is a prime number because if you multiply with anything you won't get 5. So 5 is a prime number. 7 is also a prime number. Then 9 you can write as 3 and 3, right? So it is not a prime number. 11 you cannot be written as any other number, so it's a prime number. And 13 is also a prime number. 15 you can write as 3 into 5 and it is a multiple of 5. So you can strike it down. Then 17, you cannot written 17 in terms of any other. So 17 is a prime number and 19 is also a prime number. So this method is called sieve of arithmesis. Okay, this method is used for finding prime numbers and composite numbers easily. So now we are moving on to the next one, which is odd and even numbers. Okay, so odd and even numbers are very simple. All the multiples of 2 including 2. They are all even numbers. For example, 2, 4, 6, 8, 10, 12, 14, etc. Okay, these are all even numbers. Leftovers 1, 3, 5, 7, 9, 11, 13, they are all odd numbers. So you can see here 2, 4, 6, 8, they are all even numbers, and 1, 3, 5, 7, 9, they are all odd numbers. And it is really easy to find which number is even and which number is odd, even in big numbers. For example, 4, 8, 2, 1, 1. So this number, if you want to find whether it's even or odd, you can use two methods. One, divide this by 2. If you get remainder 0, then it is even number. If you get remainder any other, then it is odd numbers. But it is really odd, or it takes time to do so. In easy way, you can see the last number. Okay, if this number belongs to 2, 4, 6, 8 or 0, then it is even number. If some other number other than this comes, then it is odd number. And 2 is the smallest even number, because before 2 you have only 1, right? So 2 is the smallest even number and it is a prime number 2. 2 is the only even prime number. Every other primes are odd numbers only. Okay. Okay. So now we are going to solve the exercise problems. First one. What is the sum of any two odd numbers? Okay, so they asked us what is the sum of any two odd numbers. If you add any two odd numbers, you will get a even number. Okay, for example, you take 3 and 5. 3 in your mind, 5 in your finger. 3 after 4, 5, 6, 7 and 8. So this is even. For example, you take a little bit bigger number. 17 plus 13. Okay, so 7 plus 3 will be 10. 0 remains 1. 1, 2, 3. Here you have 0. This is even number. So if you are adding any two odd numbers, you will get the even numbers. You can check with any numbers, any two odd numbers. Next one. What will you get if you add two even numbers? If you add two even numbers, you will surely get even number. For example, 4 and 8. 4 plus 8 is 12, 8 which is even. Or 30 plus 40, 0, 7. This is even. So if you are adding any two even or any two odd numbers, you will get even numbers only. Okay. So next we are going to see true or false. The sum of three odd numbers is even number. if you sum two odd numbers, you will get a even number. But if you add another number, another odd number to the even number, you will get a odd number. For example, odd number 3, 5. Okay, you will get 8. Another 3. 8 plus 3 will be 11, which is odd. Okay, so first one is false. Second one, the sum of two odd numbers and one even number is even. Yeah. If you adding one odd number plus one odd number, 3 plus 3 will give you 6. If you are adding even number with even number, you will get even number. So second one is true. Third one, the product of three odd numbers is odd. Yeah, if you product two odd numbers, you will get a odd number, and then if you again product it with a odd number, you will get a odd number only. So third one is true. If an even number is divided by 2, the quotient is always odd. If you, so for example, see, if you divide a even number with 2, you can either get odd number or even number. You cannot say you will only get even or only odd. For example, if you are dividing 8 with 2, 2 4s are 8, which is even. So if you are dividing 6, 2 3s are 6. So here you got odd, here you got even. So we cannot say you will get only odd or even. Both we may get. So fourth one is false. And E. So all prime numbers are odd numbers. No, we know that 2 is a prime number and it is a even number. So that is false. Prime numbers do not have any factors. Prime number have factors, but they have only two factors, themselves and 1. So that is also false. Next, sum of two prime numbers is always even. See, there is not only odd prime numbers, there are even prime numbers too, like 2. So if you are adding even with odd, you won't get even. So that is also false. 2 is the only even prime number. Yeah. 2 is only even prime number. That is true. Then I. All even numbers are composite numbers. False. True is 2 is a prime number. So last one. The product of two even number is always even. Yeah, the product of two even numbers will always give you even number. Okay. So they have given you a number. For example, 13 and 31. They both are prime numbers, and they asked us to find the same set of prime numbers. For example, 13 is a prime number. If you mingle it like 31, they are also prime number. They asked us to find this kind of prime number below 100. So what are these? You can say that 23 and 32, 17 and 71, and 97, 79. By sieve method, you can actually find more numbers like this, and 33 also, oh no. So like this, you can find more numbers. Okay. So next question. Write down separately prime number and composite number less than 20. Like I said in the sieve method, just write a table. Okay. 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So now we are going to strike down all the composite number. This is neither prime number nor a composite number. This is prime, this is prime, this is no, this is prime, this is composite number, and this is prime, composite number, composite number, composite number. Prime, composite, prime, composite, 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 prime, composite, prime, and composite. So now after this you can actually write. First you have to leave one out of this. Okay, so 2 prime numbers or 2, 3, 5, 7, 11, 13, 17 and 19. So composite number. You can find more prime and composite number by this method. Okay, so 4, 6, 8, 9, 10, 12, 14, 15, 16, 18 and 20. Okay. Okay. So in 5th question they asked what is the greatest prime number between 1 and 10. You know, the prime number between 1 and 10 you have to write first. First one 2, 3, 5, 7. Okay, so in this 10 is the greatest. So 10 is the greatest, 7 is the greatest prime number in 10, between 1 and 10. So 6th one. Express the following as the sum of 2 odd prime numbers. 44. Okay, they asked us to express this as a sum of 2 prime numbers. You have learned about framing a problem, like the same way you have to frame a problem for this in a way that they are both are prime numbers. Okay, 44 you can write 13 plus 31. 3, 1, 4 and 1 plus 3 is 4. Next, you can, next one 36. 36 you can say 23 and 13. 23 is a prime number and 13 is a prime number. So 6 and 3. So C. 24. 24 you can write as 13 and 11. You will get 24. And D. 18. 18 can be written as 11 plus 7. So 18. Okay. Next one. Give 3 pairs of prime number whose difference is 2. 3 pairs of prime numbers whose difference is 2, which means if you are subtracting one prime number from other, you should get 2. Okay. For example, 3 and 5. If you minus 5 from 3, you will get 2, or 7 and 5, 2. 11 and 13 and 11, you will get 2. So 3 sets, 3, 5, 7, 5, 13, 11. Okay, find one more pair of such prime number. Now, which of the following numbers are prime? First one, A 23, B 51, C 37, 26, D. Now look at it. It cannot be divided by 2. It cannot be divided by 5 or 7. For 3, what I told you, you should add both of this. If you get number divisible by 3, then it can be divided by 3. So 2 plus 3 is 5, which cannot be divided by 3. So A is a prime number. B, it cannot be divided by 2 or 5. So add 5 plus 1 is 6, which can be divided by 3. So this is not prime number, it is a composite number. C, 37. It cannot be divided by 2 or 5. So for 3 you have to add, right? 3 plus 7 will be 10, which is not divided by 3. So this is prime number. and 26. 26 can be divided by 2, so it is not a prime number. Now, write 7 consecutive composite numbers less than 100 so that no prime number between them. So we have to find continuous prime composite number, no prime number involved. So in your book they have given you the sieve method, right? In that, look at it and see whether you can find 7 continuous composite number. See, you can say that 90, 91, 92, 93, 94, 95 and 96. These all are consecutive numbers and composite numbers. Okay. So, 10th one. Express each of the following numbers as a sum of 3 odd numbers. Now, they have given 21, 31, 53 and 61. We have to express them as the addition of 3 prime numbers. First one we have 21. You can say 13 and 11, 13 and 7, 13, 5 and 3. So, you will get 3 plus 5 will be 8, 8 plus 3 will be 11, 1, 1. So, 2. Next, 31. You can write it as 13 plus 11 plus 7. So, 3 plus 7 will be 10, 11, 1 remains 1 and 31. Next, 53. 53 can be written as 43, 7 and 3. So 3 plus 7 will be 10, 10 plus 3 will be 13, 13 plus 1, 5. So last one 61, 43 and 11 and 7. So 7, 3 plus 1 will be 4, 4 plus 7 will be 11, 11, 1 remainder and 1 plus 4 will be 5, 5 plus 1 will be 6. So 11th question, they asked, write 5 pairs of prime number less than 20 whose sum is divided by 5. So we are going to write down prime numbers less than 20. On adding them, we will get a number which can be divided by 5. Okay, so less than 20 prime numbers which can be divided by 5. First, 2 and 3. So 2 plus 3 will be 5 which can be divided by 5. Then 13 plus 7 will give you 20 which can be divided. 17 plus 3, 20 and 19 plus 11 will give you 30 and 17 plus 13 will give you 30. So these are all the numbers. On adding them you will get 5, 20 can be divided by 5, 20, 30 can be divided by 5. Find more numbers like this. Okay. Next, fill in the blanks. First one, a number which has only 2 factors is called, only 2 factors means prime number. So prime number is the answer. So next one, a number which has more than 2 factors is called composite numbers. Next, one is neither a prime number nor a composite number. smallest prime number is 2 because 1 is neither a prime number nor a composite number. 2 is the smallest even prime number. Okay. So next one. The smallest composite number is 1 is no, 2 is a prime number, 3 is a prime number, 4. So 4. And last one. The smallest even number is 2. With this, we have come to end of exercise 3.2. Okay. In the next class, we will see you with the next exercise. Bye.